Hi, Mrs. Ramirez here. We are working on Module 2, Lesson 3. We are interpreting and computing division of a fraction by a fraction. We're really working on fractions that have the same denominators today. So we did the classwork or the opening exercise in class. Let's check out example 1. So they give us 8/9 divided by 2/9, and I can think of this as 8/9 broken into groups of 2/9. I really like dividing fractions that have the same denominators. It really is something I can visualize and I can see it, and I can therefore figure it out really easily. So they wanted to point out the unit forms. They said, write the expression in unit form. So we'll write it in a few different unit forms. What they're saying is the denominators are the same. So that's my unit form. It is like saying 8/1 broken into groups of 2/1, which equals 4 groups of 2/1. So it's like doing 8 divided by 2 equals 4. Okay, I could also do something like 8/10 broken into groups of 2/10. Here's where my units are the same. The same thing is, it's going to be 4 groups of 2/10. So it's like if I put it in the decimal form, 0.8 broken into groups of 0.2 equals, okay, I don't have my decimal over here because it's 4 whole groups of the 2/10. Okay, so it's 4 groups of 2/10. Okay, so that's what they're looking at. What we have here, the same unit, is 8/9. And it's broken into groups of 2/9. So that's still going to equal 4, and it's going to be 4 groups of the 2/9. And let's look at a model for that. So I'm going to draw, it's kind of a tape diagram with 9ths. So therefore, if I make this 9/9, that's my whole, and 9ths all goes from thirds. So I'm going to work on thirds first, and then all of my thirds, I'm going to put in thirds right there. So there's 3, another group of 3, and another group of 3. Close to even. Okay, so I don't have the whole, I have 8/9. So I'm going to color in with my colored pencil 8 of the 9 to show it's 8/9. Okay, and so this entire thing is 8/9. And what I'm doing is breaking that 8/9 into groups of 2/9. So I've got my 8/9. I'm going to break it into groups of 2/9. There's one group of 2/9, another group of 2/9, another group of 2/9, and I do have another full group of 2/9. So therefore, it looks like 1, 2, 3, 4 whole groups of 2/9, which is what we looked at over there as well. So if I were to divide that using common denominator algorithm, because the units are the same, 9 broken into groups of 9 gives me one group of 9. 8 divided by 2, 8 broken into groups of 2 gives me 4, and 4 over 1 is 4 wholes. Okay, I could also use copy.flip in this situation. It's just not as nice or easy to use when you already have common denominators, but I'll show you it. Copy.flip. I copy the first one. My first opposite is make, divide to multiply. My second opposite is flip, uh, inverse the inverse this fraction to make a reciprocal. Actually, what I see here is a 9 in the numerator, a 9 in the denominator. This is a giant 1. It's just on its side. So therefore, it adds to 1. So therefore, 8 times 1 is 8. 1 times 2 is 1. Nope, sorry, 2, sorry. And therefore, 8 over 2 equals 4 wholes. When I have a situation like that, my 9 over 9 could be in 2 different fractions. So there's my giant 1. It just spans the numerator and denominator of 2 different. I can simplify before multiplying, and then I don't have to simplify after. Happy learning!